Good morning, myself Dr. P. Kantimati, Assistant Professor, Faculty of Physics, SRM Madurai College for Engineering and Technology. Today, I am going to talk about concept of mechanics. In this topic, we are going to talk about some few topics. One is basic concept of mechanics. Next, basic quantities, Newton's laws of motion, mass, force, velocity, acceleration, and gravity, relationship between mass, force, and acceleration, types of motion, importance of mechanics, and then conclusion. First, we are going to see about mechanics. Mechanics is a branch of physics that deals with force and the effect of force on the body at rest and bodies in motion. The science of mechanics is therefore entailed when studying the force acting upon the girder supporting a boiler, the leverage exerted in the tightening a bolt with a wrench, the work done in the pumping water to a supply tank, or the work done in the raising an elevator in a set. Each of these processes involves the action or movement of the forces. There are two branches of mechanics, namely statics and dynamics. Statics nothing but deals with the forces and their effect on rigid body at rest condition. Dynamics deals with motion and the effect of the forces acting upon the rigid body in motion. Next, we are going to see about basic quantity. Basically, there are two quantities, scalar and vector quantities. Scalar quantity nothing but magnitude only. Example for scalar quantity, mass, time, temperature. Vector quantity is nothing but magnitude and the direction. Example for vector quantity, velocity and forces. So these are the basic quantities, scalar and vector quantities. Next, we are going to see about Newton's law of motion. Many of the problem in mechanics deals with force and motion, and it is important for the student to know and understand the law of motion. These laws were summarized by Newton as follows. First one, every body will continue in a state of rest or uniform motion in the straight line unless it is acted upon by an external force. And second is the rate of change of motion is proportional to the force producing the change and take place in the direction in which the force acts. The third one is that to every action there is an equal and opposite reaction, or when one object exerts a force on a second object, the second object exerts a reactive force of equal and magnitude the opposite direction on the first object. So the first law states that an object will not change this motion unless a force acts on it. The first diagram we can see the first law. An object will not change its motion unless force acts on it. The second law we can see the second uh, image. The force on an object is equal to its mass times its acceleration. The third law we know very well. The third law, when two objects interact, they apply the force to each other of equal magnitude on the opposite direction. So these three images will clearly talk about first and second and third law. So first law, an object will not change its motion unless a force acts on it. The second law says that the force on an object is equal to its mass times its acceleration. The third law, when two objects interact, they apply the force to each other of equal magnitude and opposite direction. Newton's law of motion, already we know, body remains the first image you can see. Body remains in the state of rest or uniform motion unless acted upon by a net external force. And second law, the amount of acceleration of the body is proportional to the acting force and inversely proportional to the mass of the body. Force equal to mass into acceleration. The third law, For every action, there is an equal but opposite reaction. If an object A exerts a force on object B, then object B will exert an equal but opposite force on object A. So these are the three important Newton's law of motion. Next, mass, force, velocity, acceleration and gravity. Mass, force, velocity and acceleration are all related and must be clearly defined and understood. Mass. Mass is the quantity of matter a body contains. The unit of mass in the SI system has been chosen as the kilogram. And force. Force is nothing but force may be defined as the any direction on a body which tend to change in its size or shape, its state of rest or state of motion. In the unit of force is called Newton. Next, acceleration and velocity. To understand what acceleration is, it is useful to understand what velocity is. So first we can see about velocity. Velocity is nothing but rate of change of position, that is, it is a change in the position that occurs during a given time. The unit of velocity in the SI system is the meter per second. So now we are going to see one example for how to calculate velocity. We can take one example. If a body moves on the x-axis, see picture below. If a body moves on the x-axis, picture flow from 10 meter to the 30 meter position in 4 seconds, then would have changed position by 20 meter in 4 seconds. What was its velocity? So what is meant by velocity? Change in the position to the time. So here now we are going to calculate velocity. Velocity equal to change in the position to the time. Here change in the position from 10 to 30. So total different distance is 20 meter. By the time is 4 seconds. So 20 meter by 4 seconds equal to 5 meter per second. This is the velocity. Velocity 5 meter per second. This is the way to calculate velocity. Okay. And next, acceleration. Acceleration is rate of change of velocity. That is, it is a change in velocity that occurs during a given time. The unit of acceleration meter per second square. So for this acceleration, again we are going to see about examples. Okay. If a body is moving toward the right at a velocity of 10 meter per second and 4 seconds, later it found to be moving to the right at a velocity of 30 meter per second, then would have changed velocity by 20 meter per second during 4 seconds. What would rate of acceleration have been? So we know the acceleration is change in the velocity to the time. So here change in the velocity is 20 meter per second. The time period is 4 seconds. So acceleration 20 meter per second by 4 seconds equal to 5 meter per second square. So this is a way to calculate acceleration. The next, relationship between mass, force and acceleration. Force, nothing but mass into acceleration. F equal to ma. This is a Newton second law. Okay. So unit of mass in the SI system is the kg and unit of acceleration or meter per second square. Then force equal to mass and acceleration, product of mass into acceleration, kg by meters second square. In the SI unit, the force, unit of force kg meter per second square is called a Newton. That is 1 Newton equal to 1 kg into 1 by meters second square. So relationship between mass and force and acceleration. This means if a force of 1 is applied to a mass of 1 kg, then that mass will accelerate at 1 meter per second square. Or if a mass of 1 kg is observed to the accelerating at 1 meter per second square, then there must be a force of 1 Newton acting upon the mass. Or again, if an unknown mass is found to be accelerating at 1 meter per second square under the influence of a 1 Newton force, then that mass must be 1 kg. Clear? Now we are going to see third example for this. A mass of 1000 kg is to be accelerated at 15 meter per second square. What force is required? Solution for this problem: force equal to mass into acceleration. We know the formula. So mass is 1000 kg. Acceleration 15 per meter square. So we can substitute the value of this. Force equal to mass into acceleration. So 15,000 kg meter per second square or 15,000 Newton or 15 kilonewton. This is a force. This much amount of force is required. Okay. Since the Newton is relatively small unit, kilonewton is often used. 1 kilonewton equal to 1000 Newton. Next, acceleration due to gravity. If a body is within the Earth field of gravity, there is an attraction to the Earth center due to pull of gravity. Bodies which are allowed to fall will fall toward the Earth at an increasing velocity due to the force of gravity. The velocity will be bound to increase by approximately 9.81 meter per second during the elapse of each second of time. That is referred to the acceleration due to gravity. Acceleration due to gravity, change in velocity to the time. Here, change in the velocity 9.8 meter per second. Time is 1 second. So, acceleration due to gravity 9.81 meter per second square. The acceleration together with its value should be remembered as it is of great importance when dealing with mechanics problem. Next, force of gravity. Since acceleration due to the Earth gravity may be taken as 9.81 meter per second, then the force of Earth gravity acting on a mass of 1 kg will be force equal to mass into acceleration. Force is, how to calculate force? Mass into acceleration. So mass is 1 kg, acceleration is 9.81 meter per second square. So force equal to 9.81 kg meter per second square or 9.81 Newton. The direction of this force will be downward. Thus, a mass of 1 kg on Earth surface will be subjected to a downward force of 9.81 Newton. Example for this one: a body has a mass of 200 kg. What will be the magnitude of the force due to Earth gravity acting upon the mass? Solution: force equal to mass into acceleration. We know the basic formula, mass into acceleration. So acceleration due to gravity 9.81 meter per second square. So force is here to be calculated. Force equal to mass into acceleration. So mass of the body 200 kg, acceleration 9.81 meters per second square. So 1962 kg meter second square. So force equal to 1962 Newton. Next, weight. Weight is nothing but the mass of the body is unchanging and does not vary according to its location. The force of the gravity on a body varies from location to location, depending on the value of acceleration due to gravity. The value 9.81 meter per second square is only an average value for the acceleration due to the earth gravity on the surface of the earth. It is much less at the height of 50 km above the earth surface. Next we are going to see about pressure and force. Force is previously has been defined as the action on a body which tends to change its size or shape, its state of rest or its state of motion. In the SI system, the unit of force is called the Newton. Next, pressure. Pressure is defined as the force per unit area and act in the direction normal to or right angles to the surface. Next is work, power and energy. Work. If a force is applied to a body and causes it to move through the distance, then work is done. Work is the product of the force applied and the distance moved. Work done equal to force into distance. Already we know work is the product of the force. Force is in the unit of force is Newton. Unit of the distance is meter. So force into distance. Therefore, the work done when a force of 1 Newton moves through the distance of 1 meter is 1 Newton meter. The unit of work is called a joule. 1 joule equal to 1 Newton meter. Next is power. Power is the rate of doing work. It is the quantity of work done in the given time. Power equal to power is the work done per unit time. Unit of the power is joule per second. Because work done unit is joule, time is second. So unit of the power is joule per second. Next topic is energy. Energy is the defined as the capacity of the body or substance to perform work. The study of mechanics is concerned with the two forms of mechanical energy. One is potential energy and one is kinetic energy. Potential energy is the ability of the body to do work by virtue of its position. Kinetic energy is the ability of the body to do work due to this motion. Next is types of motion. There are four types of motion: linear motion, another one is circular motion, third one is rotational motion, fourth one is periodic motion. These are the types of motion: linear motion, circular motion, rotational motion, periodic motion. So in this picture clearly talk about linear motion, rotational motion, circular motion, and finally periodic motion. The first name is linear motion. Linear motion, motion in the straight line. The car moved in the straight line. The second, rotation motion. Rotation motion, the wheel rotated in the circular path, rotatory. The circular motion is about axis. The particular particle rotate about an axis. This is a circular motion. The fourth one is periodic motion. Periodic motion, the motion that repeats itself after a certain time. Example for this periodic motion is clock. Okay, pendulum. So these are the types of motion: linear, rotational, circular motion, and periodic motion. Next, importance of the mechanics. What are the importance of mechanics? Foundation for engineering, robotics, space science. Mechanics is the foundation for engineering, robotics, and space science. Daily applications. Mechanics concept daily applied in daily application, vehicles, machines, and construction buildings. Next, conclusion. From this, all the concept we conclude applied mechanics forms the backbone of modern engineering enabling the analysis and design of mechanics, vehicles, structures, and systems. Core concepts like space, mass, time, force help understand and predict how materials and systems behave under the different conditions. Statics and dynamics, including kinetics and kinematics, are used in robotics, automotive crash analysis, and structural safety assessment. Fundamental laws such as Newton's law of motion are applied in the field like aerospace, engineering, biomechanics, and renewable energy system, wind turbine design. With advancement in technology, simulation tools, and AI-based modeling, now integrate mechanics principle for smart manufacturing, autonomous vehicles, and motion in planning drones. Thank you.